Yeah.
All right, so we are Renee, James, and Scott Miller. I'll let you figure out which one of us is which. And we are here from Sam Houston State University. Title of our talk, Robotic versus Simulated versus the Real Thing. Essentially, what we wanted to do is we're looking at, so most of us want to give students some sort of an idea of what it means to observe or work with real data or whatever, but this can come in a number of different forms. And so we're looking at the various forms that you can use, the different methods. And then we also administered some surveys to teachers, to students, and we're going to be looking at the feedback we got from them in terms of the various uses that they have, the perceived barriers behind it, and the educational outcomes. So first, want to just sort of define the different types of observing that we're going to be talking about. So first, we have robotic/remote observing, and this could be anything like using the Parkes telescope, the Pulse at Parkes project, where you can work with data gathered there, or the LCOGT data. We have simulated data, where you're essentially using something that's already canned, if you will. Something like CLIA Labs, where it simulates with the telescopes opening and get the sound effects and everything, and the kids ooh and ah over that or not. But they can actually gather data, although it's all simulated. Or something like the NAP Labs out of Nebraska, where you can look at binary stars orbiting around each other and look at the data from there. And then finally, of course, the real thing, where you can actually gather data with a telescope of some sort. But it doesn't even have to be limited to telescopes. The real thing could even include using sun spotters to observe the motion of the sun across the sky due to the Earth's rotation, or sunspots, something you can easily do during the daytime, like someone else said, even during lunchtime. But it also includes your typical observing at nighttime with telescopes. To put us into context, our institution, we are both professors at Sam Houston State University in Huntsville, Texas. It's a regional university in East Texas, so we deal with students typically in that area. We get some students from out of state, but most of our students are from that general area. Currently, we have roughly 20,000 students, but we're growing every day, well, every semester. Over 50% of our students are first-generation students, and we also have a large minority population. And 71% of our graduates are considered at risk. So that's the type of students that we are working with. In terms of our department, we are the Department of Physics, not Physics and Astronomy. We're not bitter. Sorry. We just hired our 8th faculty, so we are now 8 tenure and tenure track faculty, but only 2 of us are astronomers. The rest of them are physicists. Anyway, we have 2 intro classes. We have Solar System Astronomy and Stars and Galaxies, and between those 2 intro classes, we get over 1,000 students per year coming through our intro classes. It's a highly popular set of courses. In our department, we give about 10-ish physics degrees annually. So we are a small department, but sustainable. And we do have 1 upper-level astronomy class, but we also have a minor in the making. We just got approval to create an astronomy minor for the physics majors, but we are also in the process of creating an astronomy minor for liberal arts majors. We just got 2 new courses approved that we will be offering in the near future, starting next year-ish. In terms of the tools that we use in our classes, we have computer labs with access to simulators. So we do a lot of the NAP labs, the CLIA labs, Stellarium, things like that, to give students some of the simulated data to work with. We have a number of sun spotters that we can use with our students so they can actually go out and observe sunspots when there are some, if it's not a solar minimum, or at least to track the motion of the sun or the Earth's rotation by watching the sun move. We have a planetarium. It was recently updated, so it's pretty state-of-the-art these days. It's about 24 students comfortably, and we can do a number of things in there. We have an off-campus observatory with a number of telescopes, including a 16-inch telescope in the dome that is computer driven. We have a 24-inch Dobsonian, two 8-inch telescopes. And so we use our observatory quite regularly with our students. And then we also just recently, or at least Renee did, gained access to the LCOGT as of September of last year. In addition to all of that, we also have one part-time astronomy staff member. And the reason why we want to bring this up is that to deal with these 1,000 students that we have every year, it's just us, the two of us, and him part-time. We can't even hire him full-time, but he runs our observatory. He does planetarium shows, public outreach, but that's it. We don't have graduate students, so our TAs aren't even science majors. They are students who took our course as a general elective and did rather well, and then we hire them on to be TAs. And so they sort of get thrown in the deep end. Well, not quite. We train them, but they learn the science as they go along, and we make do. So as in preparation for this, we created a survey that I believe was sent out to a number of people here, but we also posted on Astro Learner and anywhere else? I think that was it.
The Astronomers Facebook page as well.
There we go. Yeah, so we tried to send it out to as many people as we could, and we got a number of responses from that. And based on that response, we wanted to look, one of the things that we wanted to look at was what type of educational objectives do you have when you are trying to use or involve your students in some sort of observing project of one type or another. And in looking at the responses that we got, we found that they sort of ran a gamut, a spectrum, if you will, of objectives from just a general awareness of the skies. Okay, guys, look up. Look, they're stars. You know, students these days, they don't look up, they don't appreciate anything. To the gee whiz factor. And this morning, when Tim was asking people, you know, what your objectives are, someone was saying something along these lines. You know, we want them to ooh and ah over the nighttime sky. But then also getting a little bit more in depth. We want students to at least know the process that astronomers go through in gathering the data. Or going even further to actually know how to go about obtaining data, or even interpreting the data. And then if you go all the way to the other end of the spectrum, the full experience from start to finish. And these were the types of responses that we got from people who answered our survey. In addition to asking for the types of outcomes or objectives that you're looking at, we also asked for your institution. And so this graph represents, based on the type of institution, generally what type of outcome people or objectives people were looking for. And so the different gradations and colors are telling you the likely or how many people answered in each. So if you looked, for example, down at the high school level, high school teachers, while they appreciated or they want their students to sort of ooh and ah over things, a lot of them also really want to go so far as to have their students know how to interpret the data that they are gathering, whether it's through a telescope or simulations or whatever. They are really going for that higher end objective. While if you look at, for example, non-R1 universities, there's a lot of just wanting them to be aware of what's out there, to track the motion of the sun over the sky over time, or to actually observe the phases of the moon, and to just be aware of what's going on. And we're going to talk a little bit about why it might be that they focus more on that end than the others. Okay. We also looked at the educational objectives as a function of the likelihood of them using the various different methods, and the little bar at the bottom is covering it up. So we have simulations, hands-on observing, real-time robotic / remote observing, or asynchronous robotics and remote telescopes. And so what you can see here is that a lot more people tend to focus on the simulations or the hands-on observing. Robotic and remote observing isn't used, or at least implemented quite as much based on the feedback that we got. Is there a laser pointer on this thing? And if so, which button? What's that? just above the arrows. Hey, look, I can point. Woo. So if you look at the red bars, that's more the robotic and remote observing, and you can see that for people who are just going into the awareness and the GWIS, robotic telescopes doesn't really suit their needs that much. It's more so the people who are wanting to do more of the higher end stuff, the interpreting data and the full experience, that tend to rely more on those things. But as for the others, we see high numbers across the board based on what they are trying to accomplish with their students. If we focus in just on the types of institutions that are similar to ours, and we put us somewhere in the 4-year undergrad or the non-R1 institutions, you can see that of those that identified as that no one identified saying that they were doing real-time robotic observing, and only a few were doing the asynchronous, but that's still large numbers of simulations or hands-on. And of the 4-year and the non-R1s, no one indicated that they were looking for their students to gain that full experience objective. We also asked, what are some of the perceived barriers? If you're not using one type of tool or another, why are you not? And so again, the colors are for simulation, hands-on observing, real-time or asynchronous, robotic/remote. For those, if you look, so, the first column represents that they found another method that they think works better for them, one of the other different methods. But the other kinds of perceived barriers that they have are no money, no time, no know-how, no value, or something else. And it seems that the biggest obstacle or perceived obstacle that people have is this perception that it costs money for everything, except for very few think that there's for the simulations that money is an obstacle, but for the others, to actually have an observatory or use a robotic or a remote telescope, that there is this money issue behind it, and that this seems to be what is preventing a lot of people from considering even using it. Yeah. Between the no time, say that again. Okay, so here's no time, here's no money. So, and I just hit a button. Okay.
And a button.
There are way too.
Stop hitting buttons, Scott.
Him. I blame him. So from no time, so this is 10 to 25. So I'm trying to remember exactly if that's a percentage or not. Yeah, so it's I can say it's twice as many. So I want to say so we're looking at twice as many people saw some sort of barrier due to, and I think this number is number of people. So twice as many people saw that no money was a bigger barrier than no time. Does that answer your question? Okay. Right. Good question.
This is your section.
This is no. Well, you have a microphone. I thought you were going to correct me if I'm wrong. I would have to reevaluate that.
To sort of follow up on that, some people actually delineated more than one reason. Like for instance, we don't use this because we perceive it to be expensive, or we don't know how to use it, right? So people could indicate more than one thing. I don't know if that it's.
Most people put down. I think only. I'm trying to. Did they do all that apply, or did they pick more than one? Okay, then I don't.
Moving along.
Moving along. Off the top of my head, I can't remember. Go ahead.
We simply indicated using
we said, I believe the question was, what is the perceived barrier that prevents you from using something? And yeah, essentially they said, we don't have the money for it. Right. So we're not saying that this is all perception. And so part of this is that people might not be using robotics or remote telescopes because they believe there's a budget issue. We're not saying there is a budget issue, but they believe there is one. It's a perception. And so this could very well mean that people just need to be better educated to find out that there isn't a budget issue that you think there is. That's what we're trying to point out here, is these are the perceptions that they have. It doesn't mean that it's an actual problem.
Right. Another interesting perception is the little bar that says no value. These are people that indicated, I don't believe that there is any value in my class to using robotic or remote observatory. And so, you know, it gets down to, what is it that they do think has value in their class?
So part of this could just be an education thing, that they have to, you know, we need to better communicate that there is value, that there isn't this money issue. Question. So another method means the barrier that why they don't use robotic telescopes is because they believe that one of the other methods, simulations or hands-on observing, meets their educational goal. I don't need to use something else because I can do what I need to in an easier way. So there is another method that I can use to achieve my goals, and it's easier or simpler or whatever. So the last column was, there were other, you know, some people said there were other barriers and we allowed them to fill in comments. And so some of the comments that we have, for example, for perceived barriers for simulations, one of the biggest comments was technical issues, right? Essentially, for those of us who love CLIA labs, they are not updating them anymore. And every time IT changes platform, and we are about to lose our usage of CLIA because we've just updated to Windows 10. And I don't know how to run CLIA on Windows 10 yet. It was hard enough to get CLIA to run on Windows 8. So it's going to soon become a problem. And this is what a number of people told us. I love these, but I can't use them. And so whenever you deal with anything with technology, you always have to worry about, as computers get updated, will the programs get updated as well? And one of our favorite comments was, for simulations, MORDAC, Preventer of Information Services, governs campus IT policy. So that is one of the main, one of the other reasons that people said that they don't use the simulations. In terms of perceived barriers for remote or robotic observing, never really thought about it. So again, it's getting that information out there that this is an option that they can use in their class. They just might not even be aware of where to begin with it. They just hadn't really thought about it as being an option. Another problem, especially if you have one of those big audiences, you know, lots of students, too many students, not enough telescope time. If you have a class of 100 students, how do you give them all a rich, meaningful experience with robotic telescopes? A lack of institutional funding, too expensive to buy into something like LCOGT. These are some of the comments that we got about why they don't use these systems. In terms of perceived barriers to hands-on observing, adverse weather or bad location. We had some people say, you know, based on where their university or college is located, you know, in urban areas, too much light pollution just doesn't work, or it's cloudy all the time here. Again, the number of students per telescope. We are fortunate in that we have someone dedicated to running our observatory, and we have our TAs go out and help. But still, when we do our observatory, we're going for that gee whiz factor because we just don't have enough time to get the number of students rich, meaningful experiences with our telescopes. Again, number of assistants per students. The type of students, we tend to use our observatory with our introductory students to give them that ooh-ah factor, because you can just crank them through. The cognitive cost benefit is just not good enough. I want them to get the more rich, meaningful experience, and I just can't do that with a real observatory. So.
Okay, so this is now what the students think. Right? I mean, we know what we think. Have we asked what the students think about any of this? What is their perception of the things that we use in our classrooms to help them better understand astronomy, right? So in our introductory classes, again, I mean, we're sort of specific to Sam Houston State, but that's also a very similar institution to many of the ones around the planet. What we've got is an observatory that for our introductory students is there for the gee whiz factor, so they can go out and go like, dang, Saturn, that's cool, right? We do not expect that we're going to have 400 or 500 students a semester go out there and, you know, maybe take their own images of something or analyze a spectrum. We don't expect that this is going to happen. We are fortunate when we can persuade them by the fact that it's part of their grade to go 15 minutes out of town one evening a semester so that they can see something, and then they get a little stamp. You made it to the observatory, congrats, right? So we want to get them out there, right? For the things where we actually want them to learn something about things out in the universe, then what we do is we use things like this little simulation right here, which is one of my favorites. It's an eclipsing binary simulator. They can manipulate it. They can see what it looks like from different angles. They can see what the light curve is going to look like. They don't have to actually go out and try to get their own light curve for an eclipsing binary. They just play with this, okay, and manipulate that and make predictions. You know, if this one passes in front of this one, what's going to happen to the light curve? Okay, so we've got, you know, two very distinctly different goals with these two methods of observing. Okay. Now, we surveyed our students to find out what they think about how those goals are being met. And so we gave them a number of questions. We had 133 students that responded. Okay, and these are students that either have taken our solar system class or our stars and galaxies class, or in some rare cases, both. And so we said, of the things, telescope, or actually we asked separate questions for telescope and simulations, which one, or did this help you better understand how astronomers find out about the universe? Right? So with the telescopes, and the agrees are in the blues and the disagrees are in the reds. So with the telescope, very few students disagreed that getting a 5-second view of Saturn helped them understand about how astronomers find out about the universe. They agreed that, you know, 5 seconds at the eyepiece gave them a good feeling for how astronomers find out about the universe. And then when they looked at the simulations, they actually were slightly less inclined to think that that helped them understand how astronomers find out about the universe. Okay, and that was pretty consistent. Hey, we phrased the question, you know, did it seem like it was a waste of lab or class time? But then to make it all consistent with the attitudes, we flipped it. So now this is a did not seem like a waste of lab or class time. I know what it takes for them to go out to the observatory. They've got to invest several hours in a night. They've got to, you know, kind of keep track of the weather, so make sure it's a good night and organized, maybe with some people in carpool out there. All right, so this is a time investment beyond their normal classroom time that they're experiencing on campus. And so with the telescope and with the simulations, we have about 1 in 5 that seem to think that this is a waste of their time. The interesting thing is it's about the same 1 in 5. You know, if you go through the surveys, you can mash, and like, we just think it's all a waste of time. Why am I here? I just want to get my degree and go. But, you know, it's at least they recognize that it's kind of worth their time to do these things. And then when you ask, were they glad that they got a chance to experience astronomy in this way? with the telescope, oh my gosh, yes, that was amazing. We were so glad we got to experience astronomy in this way. You got 80% of them saying that they were glad that they, you know, they agree or strongly agree that they got to do this. With the simulations, I mean, I guess, kind of, mostly. You know, but there's still very few of them that are saying, no, we think that this was stupid. Okay? I was not disappointed with this method of experiencing astronomy. Okay, so again, you got the telescope on the left here, and you have about 27% of the students saying, you know what, I was disappointed with this. And when you read through the comments, you find out that the things that you sort of expect to be the source of the disappointment are in fact the source of the disappointment. You know, what disappoints students about going out to the telescope? It's cold. What's that? Mosquitoes. It's what? The dots are tiny. That's it. Yeah, and that was what we got too. You know, it was cold, it was too far, it was cloudy when we got out. I was like, well, geez, look at the freaking weather and then maybe decide to go out another night, because we have it open, what, 15, 20 times? 20 times a semester they have the opportunity to go out. So you can plan this one a little bit better. All right, so, you know, we've got a quarter of the students that really were disappointed, which is kind of weird because, you know, again, they're glad they got to experience astronomy in this way, but it was disappointing. Right? And so it was interesting that the simulation fared better on that one. And maybe it's because their expectation was not as great. Right? And they didn't go in the cold, and the mosquitoes didn't bite them, and they didn't have to worry about what was that sound. Okay? Now, when you ask an instructor what they think about the educational value versus the, you know, gee whiz impact of something, okay, this is our gee whiz and educational phase space we're working in now, all right? Now you ask an instructor, what do you think the educational value is of something like what we do, which is we run the students out there, they get to look at Jupiter and they get to go, oh, Jupiter. And then they get to move to the back of the line and they stand around a lot. And then, you know, maybe they get to see the Orion Nebula or something and they go, oh, wait, that's it? What, huh? Okay. So, you know, an instructor of a course like this is going to say, you know, I think they're going to think it's pretty cool to just see through a telescope, because I've seen enough people roll by a telescope to know that, you know, they go up there and they go like, I don't see it, oh my God, right? And then they're floored when they see something. So, I mean, I'm ranking this high on the gee whiz, but I also know that they're not learning anything. They're seeing a thing through a telescope and that's it, right? So for me, I put, you know, minimally educational, but high on the gee whiz. Now, for simulations, things like your eclipsing binary, things like your CLIA lab, where you open up the dome and you take simulated data of galaxy spectra, and, you know, you try to figure out Hubble's law based on, you know, I'm like, those are richly educational things, and I think they're kind of cool, or I wouldn't make you do them, right? I think they're going to be kind of cool, and I think you're going to be kind of engaged by this. So this is where our perception is of these two tools. And then when we ask the students where they put this in their little gee whiz educational phase space, and they are totally convinced that going out to the telescope and looking at something for 5 seconds is a phenomenally educational experience. With the simulations, they actually consider that to be less educational than going out and looking through a telescope for 5 seconds, which is interesting, right? I mean, it just seems bizarre to me that this is where they go with that. But when you look at the student comments, it's kind of clear that one of the comments that we got was, it's educational because it's gee whiz. I didn't know it was going to look like that. No, I don't know anything more about Jupiter. But I wasn't expecting this. I wasn't expecting Saturn to look like a little cardboard cutout that was stuck at the end of a telescope tube and everybody's pranking me right now, right? So, you know, to them, they got an education from an experience that didn't give them the education that I was after, right? The goal of that was different. But I mean, a number of the students had some pretty thoughtful comments. The actual telescope experience was really cool, but it was highly inconvenient. The simulations were much more accessible. They allowed for a greater scope of types of observations. And somebody talking about going out to the observatory, Jupiter was the coolest thing I have ever observed over the past 2 semesters. The simulated observations helped me in class, and I got to visually see what the professor was talking about. It wasn't as cool or fun, but it was more helpful. Okay, so you have, again, a strange disconnect between what students are experiencing and what we think they're experiencing. And again, with student comments, coolness, telescopes, just way cool, oh my gosh. Simulator, not cool. Okay, I got a screenshot of one of the simulators back there, and it looks like something that came out of like the 1990s, early 90s, Mac, something. But I mean, it was, as far as they were concerned, it was kind of boring. And as far as we're concerned as educators, it's like, wow, this is really, you can simulate a thingy. Right? But the students don't see it that way. They see it as, this is a video game that really is old school. Convenience. They recognize that the observatory was inconvenient, but it still wins in the cool factor. It's too far away. Too far, by the way, is 15 minutes. They have to drive 10 miles up a highway. They will most likely miss the turn. One person got a flat tire. I heard about that on my evaluations at the end of the semester. I'm so sorry. I will sweep the highway for you next time. Okay. It's too crowded. There's a lot of standing around. It's a lot of standing around. There's a lot of standing around. And it's too chancy. You know, maybe the weather was fine, but now it sucks. Or maybe the observing night was canceled because it looked like something awful was coming through, and then it cleared. Okay. And the simulators, even the ones that we think are cool and updated, the students look at and they want to know, do you have something that's, you know, less 1990? They think they're clunky and outdated. And I think, these are cool. Man, I wish I'd had these. But, you know, my students are not me. Now, we do have some upper level students. Those are the lower level student perceptions. We've got some upper level students. And I got to go through basically what was a giant experiment with them in the fall of 2016 by having a class where it was a potpourri. You know, we're going to do a thing here, and we're going to do this thing here, and we're going to do this thing here, and we're going to do some things. And I want you to sort of get a nice smorgasbord of astronomical observing, and I want you to learn how to communicate what you're learning about. Okay, because I had an odd variety of students. So when we have the upper level class, these guys are exposed to the observatory, and they can actually go out there and play around with things and do small research projects. And we trust them with the key to the observatory so they can do this. We would not do this with our lower level students. We have the sun spotter. Tried to do a semester-long observing experiment is the wrong word, but where they would go out and map the sunspots and maybe figure out the differential rotation, except for the small problem that if you look at the sunspots from fall of 2016, you'll find that there were none, like maybe 2 in the entire semester. And so really all we got to do was go like, oh, looky, we can calculate the rotation period of Earth by seeing how long it takes for the image of the sun to go away. We had access to actually everybody does, let's be fair, everybody has access to the Pulse at Parkes data, but I had knowledge that it existed, right? So, you know, we've got all of these pulsars that we've got information about. This is really cool. You guys can go play with some radio telescope data. You know, you can see these pulsars. We can maybe try to come up with some stuff. There was a list of questions that the Pulse at Parkes people gave us that said, you know, hey, we would really like to know if there's this, and because they've got a big, huge pile of data, but nobody's really sifted through it. Okay, and so I thought, well, I'll let my students sift through it. I'll get a good experience with radio telescope data. And so that was a failed, I say failed, multi-week project because sifting through data is boring. We have Stellarium, so that was good. And then we finally, we had access to LCOGT pre-observed data, like the canned data. And we also had the ability to propose some of our own targets so that they could do some imaging, just some, you know, your basic imaging. Like the background image was one that was proposed by one of our students. And then they got the data back, they stacked the different color filters and made that. and it was cool. Okay. Now, most of our upper level students have also been astronomy TAs, so they've had sort of the fly on the wall experience watching their fellow students at the lower level classes. Okay. And so here's the
also remember a lot of them took the lower level
yes.
classes as well.
Yeah, about a half of them had taken the lower level classes. Unfortunately, half of them hadn't, so it was kind of a weird mix of students that had clue and students that didn't have a clue. All right, so here is the perceptions. Okay, again, these are the perceptions of the upper level students about the educational versus GWiz value of all the things that we did, okay, over the course of a 14-week semester. Okay, LCOGT, that one, it ranged because they did some, sort of practice runs of creating their own color images with some canned data. So they thought that was pretty educational, but, But as they got to propose their own targets, even if it was some of the same things as they had just done with the canned data, then suddenly that really shot up in the gee whiz factor. So now it was educational and it was cool as far as they were concerned. Pulse at Parks data. Oh, that was kind of a bummer. Really low on the gee whiz. Sometimes it went all the way down to you couldn't get any farther down in the minimally educational and gee whiz. There was quite a spread. And the spread was dependent on which student you asked. Some of them had more background. They had a better idea of what it was that they were working with, and a better idea of what the goal was, and a better idea that when you are a scientist, sometimes you are just going to sift through a crap ton of data, and you're going to make a plot. And that's okay, And some of them, they really were looking for something more than that. And so they didn't really see the educational value, and they really didn't have a good time with it at all. Simulations. Now, this is a crowd that they recognize the value of these things, by golly. Finally, somebody that realizes that simulations are highly educational, or you wouldn't waste your time creating them. And they were actually, as far as they were concerned, kind of cool. Okay? But their simulations that they were dealing with were things like stellarium. So that, to me, would be considered simulated observing. And they thought they could just play with that all day long. Now, from their perspective, watching other students at observatory nights, realized, yeah, these guys are getting a really good gee whiz experience out of this. But they also realize that these students are fooling themselves. They're not getting much in the way of an educational experience out of this. Jupiter, yay. Okay.
But if you look at the observatory nights and the simulations, the way the students are perceiving them is very close to the way that we did as teachers.
Yes, your upper division students are more like you. Because they're majoring in the thing you did, it looks like. Sunspotter, that one, again, we had a bit of spread. It could have been a lot better if we'd ever had some sunspots, but even with the little tiny thing that we did, they thought that was, kind of educational-ish, and it was kind of neat. And of course, icing on the cake, taking data at the university observatory, taking your own data and doing stuff with it, because ownership makes a big difference. With canned data, where you're learning the ropes, it's pretty cool. But just telling somebody, hey, I want to get 120-second exposure of this thing, and then off goes your proposal, and then magically comes back a thing that says, oh, hey, here's your data. They don't know, right? You could be lying to them and telling them, hey, your data came in. And I think I may have, actually, for one of the groups, because I don't think theirs came in. Like, hey, it's right here. And this is so cool. It's mine. I'm the one that proposed that. Some telescope in Chile got that for me. Me, not anybody else. Okay, so yeah, the ownership is a big thing. One of the things that we found out was that in any type of observing, your visual component is really strong. Okay, I would look at, for instance, getting an image, getting a color image of something, and I would say, well, that's cute and that's neat. I like it. It's a good desktop background image. but you're not really learning anything from it. But the students, even the upper level ones, you know, this is another one of the images that they took. Even though from that image they didn't really learn anything, they still think it's a heck of a lot better than when they are looking at data. And they really are learning something. Okay? The visualization component of that adds value to every type of student that we dealt with. Okay? Being able to see the thing somehow. One of the students says, I still remember the image that came back. It was really cool. There was a sense of pride in it. Okay? One of them found just the process of creating a color image to be educational in itself. Again, you know, we as professors, we don't necessarily perceive things the way they perceive them. You know, I know that when Hubble Space Telescope is taking a picture of something, it's not really taking a picture of something. I mean, I know that these are not photographs that this thing took. I know that there's been a heck of a lot of stuff going on between, you know, the data gathering and the image that you see on the front of Astronomy magazine. But I forget that my students don't know that. And it's a really eye-opening experience for them because they now, at least this group of them, they know that a lot of it's an art form. You can go in and you can tweak things and you can change. You know, we had students that had the exact same request, the exact same image, but what they interpreted was very different. You know, this one was more greenish looking and this one was more reddish looking, and they were both happy with what they had come up with. So there was a fair amount of latitude in that one. Now with the pulsar data, they had no way to visualize anything. They had data. They had some times, they had some, you know, little blips, and they could find the peaks of the blips, and they could do some stuff. But what it wound up being was overwhelming because they had so much of it. And that's what the students said. They said, you know, the data can just be overwhelming. And this is one of the things that I sort of got when I was looking at all the variable star stuff. You know, I'm thinking, wow, that's really cool. And after about 10 minutes of it, I'm going, oh my God, that's dots, right? And that's me. And I've dealt with dots. And I got to believe that, you know, without some way to ease them into that visual component of it, that's what they're going to be overrun with dots. It's just going to be dots all the way around. Okay. One of the things that we can do, this is one of the takeaways that we got, was that you can take something like, you know, here's your pulsar data, and, you know, I look at that and I now can see, wow, here's a pulsar that was on and then it turned off and then it turned on again and then it turned off again. And then, you know, my students see that as, here's a brown and orangish looking thing. Okay, so they had no way to visualize it. That was one of the big complaints with them, was that they didn't get a sense of what it was that they were looking at. So if you have a way to strengthen something like that with something like one of these simulations, then that'll add an amazing amount of value. Okay, both educationally and in the gee whiz. You'll catch their attention on that, you know, gee whiz education phase space. Okay, a few other things. Observatory for your top 6, like Tim was talking about. You know, you got your top 6 students. The observatory is great for dedicated projects, going out doing that. There's really no comparison to that. Okay, now what you can also do is use your top 6 to improve the experience for your lower 994. Okay, so if instead of having a couple of TAs running a couple of telescopes and a line of people, you had a few other people, you know, you got your upper level students out there doing a thing and saying, ooh, I'm doing this thing. I'm doing some imaging. I'm doing some spectroscopy on this thing over here. You guys want to come see it? Now you can divert some of the students that are just standing around. And then they can see through the telescope, and then they can see the thing on the computer, and then they can go, ooh, that's even cooler than standing around. Okay, so you can improve that by having more experts out there. And that's one of the problems that we're running into, is that we have a finite number of experts, and that's a very small number. Even the sun spotter, even that little solar telescope, has amazing potential because you set that up in the middle of campus. And I did this one summer session. I had a sun spotter out because I was having my lower level students do a thing with it. And here comes the campus photographer. And he's, ooh, what you doing? And he takes a picture. And one of the students had the sun spotter set up one afternoon, and people are coming by and going, "Ooh, what you doing? Ooh, looking at the sun. Oh my gosh, it's moving. Why is it moving? Because we're moving. Oh my gosh, I never had the feeling that we were moving before now." Right? I really never sensed the rotation of Earth until just now, this instant, right here on this campus, looking at this little triangle. Okay? So I'm really hoping that one of these days we'll get some sunspots, because then it gets even better when you have things on it, right? You can enhance your experience there. And when we interviewed our upper division students, we didn't just give them surveys, we gave them a lengthy interview and lunch, incentivize. Right, I bought them food so that they would come in and talk to us for 2 hours. So, you know, there's your incentive for doing an evaluation of something. Just give them food, even cheap pizzas. Okay, but they had messed around with a SOHO simulated data experience, and they had messed around with the sun spotter. And they agreed, if there had been sunspots, this would have been way cooler, okay, than the simulated, you know, realistic, amazing data from a world-class solar observatory, right? That this little $300 thing would have been better in their experience. So that's us, okay? And that's enough about us, because actually, let's face it, we're way over time. But one of the things that we're hoping that you'll start thinking about is, what is it that you're hoping to achieve using some kind of observation? Okay, and are you achieving it? And moreover, do your students think you're achieving it? I mean, we find we thought they were here, but no, they thought they were here. Your students agree with you, and if they don't, why not? You know, where can we start bridging that disconnect? And then what are the sorts of things that are preventing or facilitating your success? So normally what we would have expected is that we would have gotten done in time. I know our banquet is starting in 23 minutes. So it was supposed to be a panel where we were going to offer, you know, lots of opportunities for discussion. So talk fast.
Your presentation reminded me of a favorite quote that I pulled up on the internet. Ralph Waldo Emerson visiting Williams College Observatory in 1865, and he saw a lot of great things. He described that, but then he wrote this. So the beauty is in the eye of the beholder, I guess, in these matters. But he wrote this: "What is so good in a college as an observatory? The sublime attaches to the door and the first stair you ascend, that this is the road to the stars. Every fixture and instrument in the building, every nail and pin has a direct reference to the Milky Way, the fixed stars, and the nebulae, and we leave Massachusetts and the Americas and history outside at the door when we come in." I just think that's a very cool quote, and it is eloquent testimony to why the gee whiz factor is significant in education. He had quite a good gee whiz in 1865 and could write about it.
Just a comment. What we do a lot of times in, I guess, the high school level is that we look at what type of learner the student is, and we try to kind of steer activities based on that. And I'm just curious if you had maybe considered that maybe different types of learners, maybe visual or auditory, they just prefer to do something that's hands-on, or as opposed to maybe like a simulation.
Good information. They're killing us this summer. Yeah.
Perhaps this is helpful to you as well as me here. I think the one missing component seems to be the amateur astronomy community. And I say that to say this: I came up as an amateur astronomer. I have watched thousands of people ooh and ah, holy crap moments, either looking through telescopes or more specifically watching me take 1-minute images of just spring stretch galaxies and watching the engagement of that occur. Me, myself, knowing people who have been doing deep sky observing for about 40 years or more, and they know more about astronomy than almost everybody in this room, believe it or not. And I think that's something that there's a little pride issue, I think, involved here, that we need to admit that there's an amateur community that, aside from the pro-am collaborations, they can be a major help in education. They are your experts you talked about up there. You can link to those people. They are around. There's about 100,000 of those just in our country that are willing to help in many cases. And it's not a criticism so much as I feel like that's a missing component here in this conference, where nobody's really talked about that as a resource. And especially if we're trying to get kids to get that gee whiz, holy crap moment, man, we're missing out on some good opportunities there. So I was just wondering if you want to comment.
We're super fortunate that the guy that you saw that was our part-time, he's paid part-time. He would live at the observatory if he could. He is, I think, like the Walker County, Texas Amateur Astronomy Association. I mean, he is that. And so, you know, we absolutely use him as a huge resource, and every now and then he will get some of the other people from, you know, the local astronomy clubs out there. But nobody wants to come up to Huntsville. And I've offered, I talk at astronomy clubs all over Houston. Hey guys, we got an observatory and stuff, and come on, you know, 80 miles north, and they go, that's Interstate 45. Thanks. So maybe I need to buy them food.
They may need that.
But yes, I mean that I would just turn the keys over to, you know, dedicated amateurs, because they are phenomenal, and they're enthusiastic and they're knowledgeable, and you know they will help set this up. It's just
yeah.
So there's actually data to support what you just said. That so on the TOAST, when we looked at different populations, the amateur astronomers, especially amateur, including the fact that most amateur astronomers have never taken a formal astronomy course, outscore everyone. Professional astronomers, instructors of astronomy, teachers of astronomy, everyone. They've got more astronomy content knowledge than anybody. So, I think it's very interesting, but that the slide that stopped your presentation was the slide on instructors' perceptions of barriers. And Tim and I are sitting over here whispering to each other, and everybody's taking all these columns. The only column that interested me is the very tiny, tiny little column where their perceived barrier is their own lack of knowledge. And
that's the know-how barrier.
Know-how barrier. That data is so reminiscent of all the research that's been done on why K-12 teachers don't do inquiry. Whatever we're calling inquiry these days, you guys know what I mean the real thing. It's the exact same list. And the problem is that the real answer is the don't know how column, and we've got so much ego bound up because we're all in science, right? And in science, knowing stuff is the thing. It's your value, right? There's so much bound up in knowing how to do everything. And the reality is when we look at professional astronomers and we look at college instructors and we look at K-12 instructors who teach astronomy, they all have about the exact same lack of know-how, which is a lot. We can't say that, or you can't publish that, because nobody will invite you to dinner ever after that. But I'm just so in love with this thing that you guys have made here, because it's a books record, so many people talking about how they don't know. And that's the community, that's the conversation that must be had, because it's all in that don't know column.
Okay, let's thank Scott and Renee for that.